Welcome to the DIY Honda Garage channel. In this presentation, we will delve into DTC U0100, which indicates that the gauge control module has lost communication with the engine control module, ECM, or automatic transmission, AT. This issue primarily concerns the gauge control module, a crucial component responsible for conveying vital information to the driver, such as speed, fuel level, and engine temperature, located within the vehicle's instrument cluster. The gauge control module requires communication with the powertrain control module, PCM, to function effectively. If this communication is disrupted, the module perceives it as an abnormal condition and stores the diagnostic trouble code DTC U0100. Understanding the functioning of these components is essential for accurate troubleshooting and restoration of normal vehicle operation. In the following slides, we will explore detailed descriptions, possible causes, symptoms, and a thorough troubleshooting guide for this DTC. The gauge control module plays a vital role in monitoring various vehicle systems and relaying this information to the driver through the instrument cluster. It communicates with the engine control module, ECM, and the automatic transmission, AT, to receive data necessary for gauge operation. Located within the dashboard, behind the speedometer and other gauges, the module relies on a robust electrical connection to function correctly. If it fails to receive data from the PCM, it cannot provide accurate readings, leading to the activation of DTC U0100. This diagnostic code signifies that the module has detected a communication failure, thus underscoring the importance of a properly functioning power and ground circuit. Ensuring that the gauge control module is capable of receiving signals from the PCM is essential for the accurate functioning of related vehicle systems. Understanding the possible causes of DTC U0100 is crucial for efficient troubleshooting. One potential cause is a failure in the power or ground circuit connected to the PCM. If the PCM does not start up normally, errors may be stored. Additionally, a faulty gauge control module itself can lead to communication issues, causing it to fail in reading data from the PCM. Another significant factor could be wiring issues, such as damaged or corroded connectors along the communication path between the PCM and gauge control module. Each of these causes can significantly impact communication and must be checked carefully during the diagnostic process. Thoroughly inspecting these components helps ensure that the underlying issue is identified and resolved effectively. The symptoms associated with DTC U0100 can manifest in several noticeable ways. One primary symptom is the inactivity or complete failure of the gauges within the instrument cluster, meaning critical information such as speed and fuel levels may not be displayed. This can lead to dashboard warning lights illuminating, signaling various alerts to the driver. Inconsistent readings may also occur if the gauges sporadically operate or display incorrect information, which can further compromise driver awareness and decision-making. Recognizing these symptoms is essential for identifying that a communication error exists and that prompt attention is required to rectify the issue. Addressing these symptoms can significantly enhance the vehicle's drivability and safety. The first step in troubleshooting DTC U0100 involves ensuring the vehicle is turned to the on mode. This action activates the vehicle's electrical systems and allows for the necessary communications check to commence. The subsequent requirement is to wait for at least 6 seconds. This interval provides the gauge control module the necessary time to attempt establishing communications with the PCM. This step is crucial, as communication communication checks need to be initiated properly before further diagnosis can proceed. Following this procedure is critical in confirming whether the issue is a transient fault or indicative of a persistent problem that requires further investigation. Proper execution of this step lays the foundation for successful debugging of the vehicle's communication network. In this step, we will check the power and ground circuit of the PCM to ensure it is functioning properly. A properly connected power and ground circuit is vital for the PCM to operate effectively. If there is a short circuit, open circuit, or corrosion present, communication issues can arise, ultimately triggering DTC U0100. Additionally, it is important to inspect the connections to the PCM itself for any signs of damage or loose wires. Utilizing a multimeter will help in diagnosing the power and ground circuits, as it can provide accurate voltage readings essential for confirming proper circuit integrity. Making certain these circuits are functioning correctly is imperative for further advancement in the troubleshooting process. After completing all necessary repairs and resets, the final step is verification to ensure that the issues have been effectively resolved. Begin by clearing the diagnostic trouble codes, or DTCs, using a diagnostic scanner. This allows the vehicle systems to reset and re-establish communication. Following this, run diagnostic tests to confirm whether DTC U0100 reappears after resetting. If the code does not return, proceed to ensure the gauge functions correctly. Checking the operation of all instrument cluster gauges is crucial, as it provides verification that the communication flow has been restored. Successful completion of these steps ensures that the vehicle will operate normally and provides confidence that any involved systems are now in working order. To prevent future occurrences of DTC U0100, establishing a routine for regular diagnostics is recommended. Regular checks of the vehicle's electronic systems can identify minor issues before they escalate into significant problems. Additionally, periodic inspection of electrical connections, especially those related to the PCM and gauge control module, should be conducted to ensure they remain secure and free from corrosion. Proper maintenance of the electrical components will significantly reduce the likelihood of communication errors. Keeping the vehicle's software up to date may also help in mitigating communication issues that technology upgrades could resolve. Implementing these preventative measures enhances the robustness of the vehicle's communication network and prolongs the longevity of its components. In conclusion, understanding DTC U0100 and the communication dynamics between the gauge control module and the PCM is essential for effective troubleshooting. We have highlighted the critical steps involved in diagnosing the issue, starting with initial checks and ending with thorough verification processes. Acknowledging the importance of regular maintenance and timely inspections is paramount in preventing future occurrences. The relationship between the components must be properly maintained for optimal vehicle performance. Remember, proactive approaches to diagnostic and maintenance work can save time and costly repairs in the long run. Implementing strategies discussed in this presentation will not only address DTC U0100, but enhance overall vehicle reliability. Please like and subscribe to the channel. See you next time!